invitation, and thank you for the cooperation, and I hope it will be extended in future too. And I also request all the students to be cooperative throughout the session, and hope you all will grab the opportunity. Thank you so much, sir. And now I request Professor to take over the session.
Thank you, madam.
Okay, sir.
Yeah, am I? My screen, is it visible? So here today I will just briefly talk about what is this cloud computing, fog computing, and edge computing altogether. Okay. Now this technology gains prominence because it has become far more cheap, and it has been offering so many applications. But many tend to confuse between what is this cloud, what is this fog, and what is this edge computing. So this is where we are here to talk about. And I will just brief out. Maybe there may be many more slides that I have added, but I will just brief out on what is the content of that slide rather than going in depth, because the session may be like nearly 1 hour or so, because we are starting on time. Maybe I will wrap up by the 5 hours wrap up. And coming, why this concept has come into picture is what we need to understand. Why this cloud concept as such has come into picture. This is what we have to understand. Now, as and when technology has come up, the need for computation, that is the processor and its computational power, like how many bits it is able to crunch, bytes it is able to crunch, words it is able to crunch, is increasing gradually. And the other thing is like storage capacity also requires to be added whenever this technology is coming up, and you are actually adding up more and more data, and you need to have storage for all this synchronization with the needs of the business. And again, you need to ensure that you have sufficient technology which can add up all these. Okay. Now, to make this topic more interesting, I will just add out now why this technology is more important, and how it is. Okay. Now, recently, many of our friends might have watched IPL, and you might have seen that this IPL match was live on Geo platform. And you could see that as and when you have logged in, you could see huge traffic. So this many crores of people are logged in, this many crores of people are there, this many lakhs of people are there. And you could see at peaks, like when Dhoni is playing or Dhoni is coming into ground, or any CSK play happens, you could see that traffic is high. But one thing we all behind, so all these things, if you look at, okay, so this topic has that answer of how things are happening. Okay? And so alignment with the needs of business is one requirement that cloud computing will handle. Needs to address the scalability issue, that is how large, how small, and how high performance computing you require, automation, then response time, then rapid prototyping means how fast you are able to deploy your products, and rapid time to production. These are technology challenges, and this is what your cloud, fog, and uh, its platforms, its computing platforms are providing, and transform data from diverse sources into intelligence and deliver intelligence to right people. So not just taking data. Data is of course very valuable. Not just data, but how do you make intelligent decisions out of this? So this is one aspect. So here you have one technology called the cloud computing. So to start with, what is this concept of cloud computing? It is an internet-based computing system technology whereby you share resources, okay, hardware resources, you share software, you share information. So these are all the three things that are very important, like resource, hardware resource, software resource, and data resource. These three things are what are shared by your cloud. Cloud computing facilitates sharing these three, and also they provide you on demand, like the electricity. What is basically the cloud computing, and it is the culmination of numerous attempts at large scale and seamless access to virtual resources. So virtual resources, we need to understand what is this virtual resource. Okay? So virtual resource is one which seems to exist, but it actually doesn't exist personalized to you, but you'll be able to use it because it is available already, and many people will be able to use that resource virtually, where virtuality, virtual concept comes into picture, and clouds make use of this virtual concept. Again, we will see what is this virtual concept. Then we have some examples of Amazon Web Services. It supports EC2 and Triple S or S3 and EBS. These are all few technologies that AWS. We need to really understand why AWS is becoming popular. So now AWS is a platform in industry. Like, let me tell you, all my friends who have gathered here, different friends. It is something like AWS. AWS is one such thing. 1 minute. So AWS is one such platform where you offer many services, not just the cloud. Not just the cloud. It offers many services. You have this as a platform in industry. So what I am now talking about Windows operating system, I am talking about Linux operating system, or Ubuntu or any other operating system. We could easily understand that all these operating systems, they are not merely operating systems when you work in industry, because your applications will be deployed, and your applications are now no longer deployed on servers, but they are deployed on cloud. Cloud will see. So these Amazon Web Services provide that cloud where you deploy your applications, and you no need to have your own defined servers, not required mostly. And this is saving much of your costs in setting up the firm or in utilizing services. So it is something like this. Now you want to sell car. Okay, you need not be a person who manufactures a car, and this is are going on. Okay? And now other platforms, cloud platforms include Azure, Microsoft Azure, which is familiar one. Then Google Cloud, then RightScale, Salesforce, EMC, Gigaspaces, then DataStax, Oracle Cloud, VMware Cloud, Yahoo Cloud, Cloudera. Many clouds are there. And you may ask why this many clouds are there, what is their specialty? The thing is like you have different problems. For different problems, you have different solutions. So different types of services you require from cloud, you have different cloud platforms also. This is the reason why you have this many cloud platforms. And many more are there, but more prominent are these things. And what is the benefit, or what is the purpose and benefit of this cloud working? So you have infrastructure less thing. So when you are really trying to use your cloud, you need not have an infrastructure like your own server need not be there. Okay, your own software building team which will deploy your server need not be there. Everything is now ready made on cloud, and you need to put your developed application, that is software that is developed into that cloud, and make it possible that you use it. And by using cloud infrastructure, we pay them as we use, and that too on demand. How much ever we want, we raise payment for that, and we use it. So again, we may get it out. Why I have to pay? Why I have to pay? Is that question that will come to your mind. So we actually, as a late user, who is at the end user, we need not actually have to pay, because Google offers many things free, and AWS up to $200 it offers free. And there may be one more cloud which offers up to some storage limit free. But that storage limit or that computation power which we offer or which we get free may not be sufficient, because you may have to really go for enterprise applications. These enterprise applications, they are highly scalable. That means that their data storage requirements are high and they are computing centric, means high computational power is required, then high performance computation may be required. In all such cases, you need to have a mechanism where you pay for the service and you use. So it is as simple as like this. For a preliminary service, it is free. And as and when you go for enterprise applications or industry applications or huge applications, definitely you can or you need to pay and use. This is how this cloud comes into picture. And as and when you need that much, you can pay. So you require some quantity X, you need to pay for that. You require 2X, you have to pay for that. You require 10X, you have to pay accordingly. So it is very flexible. That is, now you can ask me what is that I will get when I pay 2X, 3X, 10X. It is the storage, it is the computation power, it is the software, it is the application, all these things that you will get as an advantage. What are the other advantages? You have improved performance because your server is doing it for you, because some person remotely is sitting there and doing things for you where you did not have a dedicated computer. Now I will explain how things go here. Okay. Now I want to do something on a i7 system. You know, i7 system is high performance system and you may require a 32 GB RAM, but we don't have a laptop of that configuration, we don't have a system of that configuration, but I have a cloud which has more configuration or more high configuration than what I think of. So maybe as I told i7, then 32 GB RAM, but their configuration will be much more, not necessarily one CPU, but it will have two CPUs, and then it will have a storage of 1 TB dedicated to you, but where in your system it will have only 500 GB, and you have RAM of nearly 128 GB in the server, but your system will have only 32 GB. So all these things that are there over internet, the cloud, it is accessible to you. So improved performance you will get when you try to use them. Then costs are reduced because there may be a group of software that you need to purchase. Windows license, Adobe license, Oracle license, all these things you have to purchase and use. But what happens in cloud is, in cloud, one person will do everything for you. He makes things ready. All these licensed products are available there, and you can develop something out of those licensed software, and you can derive a product. But this doesn't come free. Okay, you have to pay for this, and you have to purchase this license for one cloud user license. Then you can develop product. Then you can download the executable. Then you can uh, deploy. Again, the deployment also can be on the cloud itself. Again, you require some space. Again, it is as simple as you want to build a house and you want place. Okay, when you want to buy place, definitely you have to buy place and construct a house. But now things are simple. You have an apartment, go and occupy the apartment. Now you need not have to worry about plot. You need not worry about land. You need not worry about any facilities. They are already there. You have to use. And for some cases, some cloud services they offered even software free. So that also you can, and you can pay for what you want. You need not pay for every software that is available in that cloud, but you can pay for what you want, and it will be cheap because you'll be paying it for group. It is like a TV channel. There are some group of TV channels for which you pay monthly rent and you consume them and you use them. Same here, some set of software licenses are available free and you can start using them by paying the license. And then software updates, they come frequently because licensed software is purchased by the cloud vendor, and cloud vendor always updates his software. As and when he updates, your new version of software can automatically access. And then improve document formality. So what is this document format? Okay, this document formats are same. You deploy it on cloud, you access it anywhere. The same format will be useful. It is like same format across the entire globe. You use it on the same cloud, the format will be same. Then unlimited storage capacity. You may feel like you have 1 TB space, but on cloud you have petabyte space. So what is the other thing that we need to know is our hard disk may be in terms of TB that we talk, terabyte. Okay, but when coming to the cloud, their storage will be petabytes, which is very very large. Okay, and it is very very small when compared with the size of your hard disk. Then increased reliability. So now we are using our laptops, but suddenly your laptop crashes and you feel like your data is lost, and you try to go to backup, and when you back up you are able to retrieve something, but still you feel I lost some data. Okay. But with cloud it is not the case. Even if the cloud crashes also, there will be replica servers who will be able to take up the backup and your data is never lost. Of course, all these things they don't come free for cost, and they will charge you something or the other. Then same universal document access, you can access documents anywhere. There are few advantages, including latest version availability of the cloud. Even cloud has got versions. It's supporting software versions. Then easier group collaboration. Sharing document leads to directly better collaboration. Many people can share documents, updations, then all these things they happen appropriately. Then device independence. Device independence is one more thing that happens. You are no longer a single computer or a network. So it changes to computers and applications. So what is device independence means that I use one particular operating system here. I update my document, and when I take the same document and open in another operating system, unless it is an open format, the format changes and the document doesn't appear to be compatible in other operating system. But you do it on the cloud, the same format is still there, and you access from anywhere on the globe, it is the same format. There are, of course, some disadvantages also. First disadvantage is like you require internet. Without internet, you cannot use cloud. So it is as simple as that, and internet is a must. Without this, no cloud at all. And another point is does not work well with low speed connections. Again, internet is a bottleneck for cloud computing. Again, computation is a bottleneck for cloud computing. Web-based applications require a lot of bandwidth to download large documents. Unless until you have good internet connectivity, it is not possible. Cloud computing usage is not very smooth, and there may be some features which are limited because you pay for that service, and those services are alone accessible. But your cloud may have still more high potential than what you go and prescribe or subscribe. Okay. When you subscribe, you will subscribe by economical means, but they do not mean that all services you have are accessible. But there are some services which are not comfortably accessed even through cloud. Then stored data might not be secure. Cloud data, you cannot deem it secure. There are now specialized algorithms, specialized mechanisms that are coming up to secure your cloud. So that is one prospect. And stored data cannot be lost. That is, it is replicated among so many machines, and you tend to delete on one, still it exists. Then there are some general concerns, like it may not be possible to run applications between cloud-based systems. So one cloud runs one application. It is not possible that you run it on the other cloud and ensure same service because compatibility doesn't exist. So any problem? Am I audible to all? Am I audible? Hello? Am I audible all? Anyone can reply, ma'am?
Yes, sir.
Yeah, please. So this is how again every cloud will have its own database. Like I feel you students are already studying database systems, and this database is now currently maybe SQL2, but other cloud service will be operating on MongoDB. The other will be operating on other SQLite. So there are many more databases, many more accessing platforms, accessing languages. So that makes it difficult. And we will try to understand what are the common characteristics of this cloud computing. So now why I want to concentrate on these things. Okay? There may be some general questions to our students who are particularly going for interviews. Okay. They will particularly ask, what is this cloud? Do you know any characteristics? Do you know what are the different cloud computing technologies? Some such questions I am trying to answer here in this slide. So they are massively scalable, and homogeneity is there. Virtualization you can do. Then they are low cost, resilient computing, geographically distributed, service oriented, and advanced security. So these are few common characteristics. Then the essential characteristic include broadband network access, then elasticity must be present, resource pooling must be present, measured services. Then coming to the next thing, so typical requirements and cloud models. So this is very important where our students need to be a little bit here to understand what is this cloud model. Okay. So currently, cloud computing offers three models, and we are discussing about one more model also, the service-based application programming API. So this also. So what is this PaaS? PaaS, platform as service, software as service, infrastructure as service, and the fourth model is the service-based application programming languages, SAPI. Okay. So cloud computing environment can provide one or more of these services at a cost, and, okay, and you have to pay for all this. It is something like this. You want to go to hotel, okay? So you prepare some item. You have to pay cost for that. You go to a hotel, you take food. Let us suppose that there is a hotel where you have accommodation. Okay? But it is enough that you go for food, not required for accommodation. Okay? That such service is also available, right? So hotel offers both food and accommodation, and the same hotel offers food where what is the service required by you, that is what you try to take by paying what is required. The same thing happens here also. Platform, software, infrastructure, all these are services, and you try to consume them as and when you require, and you pay for them. We will try to understand what is PaaS, SaaS, and IaaS. Now, this is where they look like the infrastructure means hardware resources, then platform as a services where you have cloud services in offering, and you can deploy some application, and service value nets they tell what is there as a service. So this is what we will discuss in next slide. Now, what is infrastructure as a service, and what things are offered as infrastructure? Storage is one infrastructure. Computation is one infrastructure. How you manage services is also an infrastructure. So there are some examples of storage infrastructure services like Amazon and Amazon S3, Amazon EBS. Then coming to compute, Amazon EC2, and then Spark Cloud, GoGrid, Tra. All these are few infrastructure services which are nothing but storage, computation, and service management. And coming to platform, so just below that, infrastructure as a service, platform as a service, there are general purpose applications, business intelligence application, integration related applications to be tested for storage. So for all these, you have different types of platforms, and we call that as platform as a service. And the other thing is software as a service, building applications. This software can be used to develop applications as per the usage or user. So there you have something for billing software, financial software, legal software, sales, productivity, then human resources. So all these are the software services that are available. You can try to use them or grab them as and when you pick. Let us suppose our university wants to use some payroll system. This payroll system can be taken from the cloud. You can take one such application from the cloud and you can start using. And you want some applications for income tax, income tax deduction. Some services are available on the cloud. Financial cloud services are available that you can use. They are ready-made software that you can use. Then we try to understand how one is related to the other. Okay? So first, Amazon Web Services, we start from the down. So it is capable of hosting IaaS, infrastructure as a service. So servers, computation, okay. So such things are available, networks, switches, such things are available in the cloud, and you can use them by connecting to them. And then some noise is there. Some noise is there. Okay. Then coming to the other aspect, what is this PaaS? So there are some applications. So platform as a service. Okay. So you can deploy your applications. So you need not specify what are your applications, but you have some application that you can deploy and others can use. Similarly, Salesforce, they deploy software as a service. There you can use ready-madely available software. You can just configure them and start using them. So this is how the hierarchy goes. Okay. So infrastructure plus platform, infrastructure, platform plus software. This is what is software as a service. So then four features that are available in today's clouds. They include massive scalability. They support large size, on-demand access. As and when you pay, you get access. Then they are data intensive, means more and more MB of data you can store. Their new programming paradigms like MapReduce, big data. I mean to say big data, Hadoop, NoSQL, Cassandra, MongoDB. All these things are latest technologies or databases that are now currently available and they are accessible to the cloud. Now you may ask me, what if those technologies are there? If those technologies are there and you need to deploy for your own application, you need to invest much. Okay? But now they are ready-madely available on the cloud and you can configure before using them. And the job is becoming a lot more easier. And what are the technologies that are enabling cloud? Okay? So you have a data-intensive, storage-intensive application, and you require a bandwidth for accessing that, and you use service interfaces, which we call APIs, application programming, and they are responsible for writing data to different virtual machines. Now, what is this virtual machine? A large storage and a large computing capacity computer. Okay. Now I want to distribute that large capacity computer or large storage to 1,000 people. Okay. Now, how is that possible that one big chunk can be shared to everyone? So there comes the concept of virtuality. So what this virtuality will do is it will subdivide this big resource, chunk of resource, that is your storage, configure storage, and then computation, all the speed of computation, internet connectivity or bandwidth, all these things it will try to divide. It will divide as it is for a single system. Now, let us suppose that I have my i7 system, I have my 8 GB RAM or 16 GB RAM with 1 TB disk. My virtual machine will create one such thing for you on the cloud. The benefit is that you can access one such high configuration system from your own laptop, even though it is i3 configuration, even though it is 3 GB RAM or 4 GB RAM, even though it has got 128 GB hard disk, but still it is capable of doing it only because you have virtual machines in place. Virtual machines are those which are quite comfortable in dividing this large set of resources to several users. Okay. And this is possible because you have multi-core architectures and you have 64-bit processors. Then what are the two categories or three categories of cloud? Specifically, there are two categories, but I try to add this hybrid cloud because this is a lot more famous. Not two categories, three categories. Heading can be three categories. So what is this public cloud, private cloud, and the most important now is hybrid cloud. So private clouds are those that are accessible only to a company or specific company, their own employees, they have their own requirements, then they have their own things. So let us suppose you have a university and you have university relevant software. Only set of students enrolled in that university can access. Then good option is to go for a cloud, private cloud. Okay. Then you go for a public cloud when many people want to use many services, and readily you cannot afford to have a private cloud because they are shared data, and you can also avail such shared things. So Amazon S3, Amazon EC2. So these platforms are there, and you have to pay for that to access things. Then the another one is the hybrid cloud, which is a mixed environment where applications run in both storage, service, computing, and some companies want them personalized or private. Some companies want to share with others. Even that is quite well possible. Okay. Now let us suppose that there is an application developed for human resource management, and this human resource management application is so good that it can be applied to any company where humans are working. Any company, let it be educational institution, let it be manufacturing, let it be any other thing, even automobile industry also. Now what happens is some set of applications or services, it needs to be used by some company, and some wants it dedicatedly. Okay. Now what happens is shared among both. So this is where a private public cloud can be shared among more than one user as and when they require and as and when they want. Okay. This is where hybrid cloud. What is the reason for going for a private cloud? Why we should go for a private cloud? We want security and privacy for our data, and we have the potential for vendor lock. So vendor can always tell this is what I want and I will not share it. And SLAs are nothing but service level agreements. So they are very much required for real-time performance and reliability. Service level agreements are those which you sign when you are asking for a cloud service. So you will tell these and all are the features that I want. No, this is like requirements. These requirements you specify before you opt for a cloud service. Then private cloud is very much required. This facility is provided by that, and cost saving happens in the private cloud. This is why you require a private cloud. Then we discuss about some cloud platforms and what is the importance. So Windows Azure is one, and it is enterprise level, and it has a number of storage, much of storage that is available, and you have to use Azure API to work with that. And there are some roles that are defined with Azure. Being being a person who wants to work with Azure, you should fit into any of these roles like a web role, worker role, blob storage, table, and now these are all the features that are available, and we need to specialize in these features of Azure so that you can do an allocated job. Now, as I told in the beginning itself, now it has become as a service provider for software. Then another one is Amazon EC2, electronic EC2 is elastic cloud. Okay. Then it is large and it can also do cloud management console, map reduce function related to big data, and Amazon machine image processing. So many things it can do, and it has also some monitoring tools. Amazon is considered to be the best one, and many of our students, they take this AWS certification before they complete their degree. And Google App Engine, this is one more comprehensive programming platform on cloud. So this is totally another cloud, but it has got its own features. So programming is very much supported. You can program your cloud. This is what is the best advantage. And you have many templates to develop applications, and you have good monitoring, and you have good management console. You can always develop applications Java, Python, and Go language. The next our shift. Now we move on to what is next topic of our discussion. What is this fog compute? Now cloud we have just come across. We have just seen what are the different types of clouds and how they will be useful. What are the characteristics? But these things they are high configuration system, and they are not readily suitable for taking up small requests. Okay? So the turnaround time will be have high server. So some noise is there. Can somebody mute? Can somebody mute? Noise is there. Yeah, now it is fine. Okay. Yeah, noise is still there. Okay, so fine. Now fog computing platform provides low latency services. Low latency means reduced delay. Now you may ask me why delays are there in cloud computing. We just thought of cloud computing has some disadvantages where response time is high. Noise is there. Ma'am, can you mute others, ma'am? Can we mute others? Yes. No, I don't know why noise is. Yes. Thank you. Again. Now, yes. Now we will again start. Okay. So coming to the fog computing, this is one actually this is little bit different in the sense that fog computing comes in between your cloud and the edge computing. So our next topic we have jumped into is fog computing. This provides low latency services. Low latency in the sense the delay is less. So you can again ask and why you feel like sir, cloud computing. 1 minute, yeah, 1 minute. I will just start. Yeah, sorry for disturbance here. Somebody was actually here. So this fog computing is one such platform which comes in between cloud and the edge computing. So you can again ask me why there is a layer called fog computing and what is. Let me tell you something. Now let us suppose that there is a huge computation power like server. Okay, you cannot disturb that high computing server with a small request. Okay, so it will waste its time for responding to the users, not to the computation. Okay, so what happens with this case is like you introduce a new layer called a fog layer. A fog layer. This fog layer can take up anything which a cloud can take up, but at the same time, it will dedicate much of its time, computation to serve the lower end devices. Lower end devices include the IoT devices, and I need not talk. You know something about it more than me. And you have mobile phones, and again, you next generation kids, you know much about mobile phones Everybody has got two now, not even one. Okay, you have smartwatches, you have many such devices which are directly connected to internet. So this is where things are growing, and you cannot burden server for that. That is there. So what should I do so that I need not burden my server? Okay, I will introduce a intermediate layer for the fog layer, and this fog layer will now directly take up with the edge device. So cloud computing level, fog computing level, and then comes the edge computing level. Now again you may ask, sir, is this very much required? All these three layers are mandatory if any mobile wants to access data from the cloud. Okay, not necessarily. It application. Some applications require all the three. Some applications require only two. Some require only one also. And again, you may ask me, cloud, fog, and edge are they required in the same order? Not necessarily. Cloud can directly talk to edge devices. Cloud and then fog can directly talk to edge devices. Not mandatory that every applications have all these three. It is not mandatory. It is not mandatory, and it is application specific, and they are very much specific to what services you are using. Okay. Now, even if we talked about this Geo at the beginning, Geo movies or Geo cinema that was able to telecast this match. So it is something similar to how Netflix does. Okay, they need not have a streaming server. This streaming server will be facilitated by the fog computing cloud. This fog computing cloud then connects to the different set of edge computing servers. Then this edge computing servers will be further connected to your mobile phones, laptops, TVs, smart TVs, XYZ. Okay. 1 minute. Yes. Now we are at this slide actually. Then what is this need for fog? Okay, at the earlier days in 1999 or 2000, okay, Cisco was the bridge. Okay, he constructed the bridge between this IoT and the cloud. Okay, and fog extends cloud to be closer to things than produce data. As I just now told, you cannot utilize your server to handle traffic, but you should use your server to have a computation specific thing. So it should more concentrate on computation than traffic handling. So what we do is we separate this layer of handling traffic to fog. So this is where fog comes into. And again, there is a disparity, okay, like cloud and the uh, end IoT devices or other applications that are there. Then what we get in cloud computing is we get fog filters, and that they are able to process intensive data, and data is now processed in milliseconds because you don't need to have to be sent to cloud. And it also happens like this fog handles in such a way that it totally virtualizes your cloud, and you feel like you are working with the cloud but your fog is working. And the benefit is that it provides more business agility because, as I told, many users are there, you have to pay. Users are there, you have to pay accordingly. Now, here comes how bandwidth is divided. Okay, how bandwidth is divided, how it is utilized, how it is effectively used. Okay, so they can have access to bandwidth, they can reserve their bandwidth minute to minute and second to second. That is still possible through fog computing. That is how companies are now reducing the amount of bandwidth that they will allocate. And they have lower operating costs, and they send loads of data to cloud only for store and data analysis, not for connectivity. Connectivity is the thing that will be taken care by fog. wearable technology like your gadgets, then well-being gadgets in health, for health you require so many gadgets you are wearing nowadays, and industry 4.0 is one such thing. These are where you have applications, and you have fog nodes which can take data and process them, and you have different types of clouds in fog also, like the public, private, and hybrid. And advantage is low latency. So time delay is less when you use fog. Video delivery is very much possible. Now this is the technology which Netflix is using, and location awareness, knows where what, then widespread distribution geographically, and mobility is also high happen. And as you see, the trend of different devices being used or increasing, so you can see that green thing. So wide area IoT devices, short range IoT devices, and PC laptops. You could see more and more devices are now connecting to fog servers. Then fog is covered already. Now, what is this cloud versus fog? We will understand difference. Now, I will try to make you clear, because cloud we know little bit, and we know fog. What is this? We will compare. Fog and cloud will coexist and work together. Fog will carry out substantial amount of communication. So, communication will be the burden of fog, not the cloud. And fog will carry substantial amount of management, control, and configuration at the end user side. So management, controlling the devices, configuring the devices. So that responsibility is with fog, not with the cloud. Decision functions are moved to cloud or keep fog away from such subtypical tasks. And fog and mutually beneficial. And you can ask me which application requires what, either a fog or cloud. Okay, the answer for that one is it is user centric. Okay, how many users are there? What is the frequency with which they will use? And what is the time for which they will use? All these things they will determine whether a solution involving cloud or cloud and fog, or only fog. So that will be decided by the application. Application will determine which you will use. Okay. Then fog architecture. So end user devices are connected to fog nodes. Fog nodes, they will provide temporary data services, and these services are further connected to the cloud. So this is the hierarchy. Devices to fog nodes to fog data services. Fog data services will upload or update the data synchronized manner with the cloud. So applications will update their data in the fog data services. So all these devices will try to, nodes will update the data in the fog data services. Once in a while, your fog data service will be updating details to the cloud back. Then this is one example of how architecture, fog architecture is really there. And producers produce data, fog node consumes it. Then at the back end, the cloud storage does storage. And consumers can again use it in the same direction, or they can take it from the cloud as and when it is required. Then fog hierarchy, this is what I was telling. You can see number one, number two. Okay, example one and example two. So if you look at one, you have a cloud and fog. The another one, you have only fog, no cloud. Okay. This is what is only fog, no cloud. Example two, cloud and fog put together. Okay. So fog, example one, fog deployment hierarchy independent of the cloud. So one did not have cloud. Two means both cloud and fog are deployed together. Okay. So where are the applications? So that is what it is discussed. ATM uses only fog, and other one, example two, which uses fog and cloud, they are used in commercial building management, solar panel monitoring, etc. Then another case of example is cloud plus fog put together with devices. Another one is directly cloud without any fog interacting with devices. So this or other examples. These are all examples where we use what. It all depends on traffic. And Netflix, how it evolved. It evolved in started with the 1998. What they did, they initially mail ordered DVDs, and 2007 they started delivering content through internet, and 2011 they have their own subscription model. And this is how Netflix will work. Okay, so blue represents the consumer electronic devices. AWS cloud services is what is in orange, and red represents the locations, like what devices. Okay, TVs connected to devices, then AWS cloud services. So the AWS cloud services monitors everything, monitors everything. Sorry. Then how layered pattern is followed in cloud computing, because there are again layers. As you might have studied in computer networks, they have OSA layers, have OSA have 7 and the other one has 4. So these models, they talk about fog computing architecture and how is the layer pattern. Then next comes the edge computing model, which is the third layer, bottommost layer, which is very, very nearer to the edge devices. Now you can again ask, sir, already fog is taking care of accessing to the devices, but what is the problem here? Why is edge computing coming again? Now, if I have connected one type of device, my fog is able to handle. But now I have sensors, I have IoT, I have mobile, I have gateway devices, I have so many devices to connect, and my fog is again getting troubled because it doesn't have all these interfaces. You have different interfaces for these devices, hence you have this edge computing layer. Edge computing. So edge computing is a distributed computing paradigm which process and compute mainly based on what devices, smart devices or edge devices, opposed to processing. Here, processing is not the trouble or problem. Here, the problem is all about how we are connecting to devices. Connecting to devices is the problem here that will be taken up by the edge computing server. Edge computing server. Then it helps to provide resources, data analysis, AI, and other sources. Now, this is the third layer. If you look at cloud computing, is the top layer. Then second layer is the fog layer. Third layer is the edge layer. Now you can ask me why you have cloud layer for storage and computation. You can again ask me why computation is there. Monitoring and connecting different devices, you have fog layer. Why you have edge layer? Edge layer is completely dedicated to how you connect devices. Because fog is becoming more hectic, job is becoming more hectic when it has to connect with different types of devices. So edge computing deals with such interface. What is this edge computing in research? Okay, it is network of micro data centers that store or process critical data and push receive data to centralized data server or a cloud storage. So their job is to push data to the next level. Take data from lower level, push it to the next level. Take data from IoT, push it to fog or cloud. Take data from mobile, push it to fog or cloud. This is their job. Okay. Typically, IoT use cases are used mostly. Healthcare devices are connected to edge computing devices or servers. And all these, they have a back-end item, which is the cloud. Then why edge computing is important? They offer new functionalities, they connect new devices, they are easy to configure, and they actually reduce the load on the server, and load on the network is reduced. Then you have scheduling algorithms to connect to so many devices. You have centralized management system. So many costs are less. So many advantages are there. Then how edge computing is, you have the bottom where you have IoT devices. Then the next layer is the interface. Okay. This interface will be there for the analytics and caching and then machine to machine interface. So that is the job what edge will do, and it will update back to the edge computing server. And what is an edge and what are the edge devices? Okay. Edge has got many use cases. So they are used in telecommunications, they are used in towers, cell phone towers. They connect to the phones, they connect to the cell phones. And the edge devices, they are like the machines or sensors or mobile phones that are there. Edge will connect, the edge devices are the one which will be connected to the edge server. Then edge architecture, how endpoints are there and how you access over the IP network and how you connect data back. So this is one architecture. And what are the benefits of Edge? Okay, they have good fast response time, they have reliable operations, they are security compliant, more secure Edge. Uh, Edge will provide security for its devices. They are cost-effective solution, interoperability between devices. All these things about your Edge computing. Then they are used in industry or smart applications. Data streams, because different devices have different processing or data transmission speeds. Edge computing will take care of processing at different data speeds. And what is this role of edge computing in healthcare? Healthcare has many IoT devices connected to the patients. Now healthcare devices are connected to edge computing server. And further is this edge computing server communicate with the equipment and take up the data. Then this is where this is what is the essence of our today's session. Okay, billions of edge devices are connected to edge computing server. Then millions of fog nodes connect to edge devices. Then cloud data centers for the fog nodes. So this is what is the hierarchy that we need to understand. Okay? And what is the difference? So edge and fog and cloud, how they are connected and what is the difference? Edge and fog computing are extensions of cloud networks, which are more like collection of servers comprising of distributed network. What is the main advantage of cloud network is that they allow data to be collected from multiple sources instead of one. At one point of time, you can access many servers and you can get data. Then while fog computing and edge computing are similar, actually intelligence and processing, data collection or other items. Data collection is the job of edge computing server, processing and intelligence is the job of fog computing. So fog computing focuses on intelligence at local network. Then edge computing focuses more on computing power and processing of data with the edge network. So this is what, okay. And again, edge computing much deals with the interfacing. So this is about our session that I have just given on very brief, and I have not gone much. And this is what I could deliver in this given time. So, Kalpana madam, so this is what is my time today. And any questions?
Yeah, sir.
Yeah, madam, I was able to deliver only this much in given time. Yes, thank you very much.
Sir, actually, we are very thankful, sir.
Yeah, madam, thank you.
Maximum of the sessions have been up to 45 minutes, but we are grateful that you have extended
No,
your cooperation for the
thank
entire
you,
session,
madam.
sir.
Thank you, madam. Thank you.
Thank you, sir.
Okay.
Sir, our coordinators will be giving this session vote of thanks, sir. 1 second.
Thank you. No problem. Thank you.
Check this one.
We from the Department of ECE, we from the Department of ECE, student coordinators of the program, extend our thanks for an informative and potential session, sir. We express our gratitude to you for accepting the invitation and taking forward our session. Hope all the students can make use of this session and bridge them to their core in upcoming years for their projects. Session is very useful. Most of our third year students are engaged in e-litmus exam. So we expect another session in future days. If you can give us time for us. Once again, thank you so much, sir. Thank you all for participating in this session. Thank you so much. One more small announcement. In the evening, we have one more session by our HOD sir, Dr. V. Vijay Kishore sir, and the attendance link will be provided in the evening session only. By 7:30 p.m., we will start the session. So everyone must join the session. Thank you. Thank you very much.